So here's the equilibrium I've promised you. So I would suggest that you grab a piece of paper or a pencil. Probably don't really need a calculator here, and be prepared to pause the video so that you can practice the questions here as we look at equilibrium. So of course, let's take a look at this first reaction. Hydrogen gas reacting with bromine gas to form hydrogen monobromide. And so anytime we're looking at a chemical equation, the first thing we need to look at is it balanced? So as we're taking a look at this, I'd say no, it is not balanced. So we would need to balance this equation by adding that coefficient of a 2. And then the next thing we want to take a look at is how would you write the equilibrium expression? This is a great time to pause the video and check back. So hopefully you're thinking that you would have written the expression with the products divided by the reactant. So it's sort of a reciprocal of the reaction. We're looking at how many products we're producing, and that HBr is squared. It's concentration. And again, whenever it's in brackets, it is concentration. And so if we're looking at the same equation, what kinds of things could disturb this equilibrium? And that could be the addition of additional reactants, like H2. What happens if we add more of those? Great time to pause the video. And of course, with that shift, more products would be produced. The reaction would shift to the right or in the forward direction. Now, what happens if to the equilibrium if HBr were added? So if additional product was added. Again, pause the video. And hopefully you're thinking that equilibrium would shift toward the left, toward the reactants, or in the reverse direction. Because with more products, then we can make more reactants. What would happen if volume were decreased? So pause the video. Alrighty, so volume is decreased. We just finished studying the gas laws, so that means pressure is increased. So as pressure increases, that means our equilibrium is going to shift toward fewer moles of gas. So I simply need to look at the equation. How many moles of gas do I have as reactants? How many as products? 2 of each. 2 moles of gas as reactants, 1 mole of the H2, 1 mole of the Br2, and then 2 moles of the product, hydrogen monobromide. So there's not going to be any shift in equilibrium. What if temperature were increased? Pause the video. So if temperature were increased, then I need to look at the delta H for this reaction. And I see that I have a negative delta H value. So that means that heat is this is exothermic, so that heat is given off. So in other words, heat is a product. When we add more products, that shifts the equilibrium in the opposite direction. So our equilibrium would shift to the left or in the opposite direction, that more reactants would be produced. Another way people like to take a look at that is that it's going to shift away from the heat. So using that delta H value, you figure out if heat's given off, it's a product, or if heat is taken in, an endothermic reaction where heat is a reactant. In this next equation here, we've got another equation to take a look at so that you can practice. Again, always the first thing, double check to make sure it's balanced. And so hopefully you're thinking, yes, it is balanced. And then we want to be able to write the equilibrium expression. So again, our products divided by our reactants. So hopefully you got that. And now what I would suggest is looking at that same equation, see if you can answer the questions here. So this is a great time to pause the video and look at that equation and answer those 4 quick questions. All right. So if we add more NO2, nitrogen dioxide, that's obviously going to shift our equilibrium to the right or towards the products. If we increase our temperature, that's also going to shift our equilibrium to the products. This is an endothermic reaction, so that means heat is a reactant. So adding more reactants shifts our equilibrium to the product side. But what if we decreased the temperature? Then it would shift in the opposite direction. It would shift toward our reactants. And lastly, if we decrease the volume. Obviously, when we decrease the volume, we're increasing the pressure, so it is going to move toward fewer moles of the gas. And in this case, there are fewer moles of reactants with only 2 moles, and there are 3 moles of products that are gases, so this equilibrium would then shift toward the left or in the reverse direction. Those are the 2 practice problems I had for you. I hope this helps you. If you need additional practice problems, just let me know.